Okay, hi. So this is going to be your first part of your midterm that you're going to be doing. So in chemistry, a lot of times when we're finished with our research and our little data notebook, we then have to create a formal lab indicating our results that we found. And most of the time, those things get published. So that is what you're going to be doing for your midterm. But in order to do that, we need to talk about what is actually happening and what you're going to be collecting. So this is going to be the first part of your midterm is doing notes on the background of each chemical bonding that I'm going to discuss here right now. So when we do this lab, there are three things that we're going to be considering, right? The first is, why do certain substances act certain ways? For example, why do oil and water not mix? Why can salt dissolve in water? Why can water boil at 100 degrees Celsius? Okay, we want to figure out why these things act the way they do. Okay, we also want to understand how atoms are held together, right? Because you can have an element, but in order to create the complex things that we have in nature, you need to be able to combine things together. And then the last thing that we're going to talk about is, why do atoms want to form bonds? And we kind of already know this with doing our ionic compound lesson. We talked about the fact that metals and nonmetals and everybody on the periodic table wants to be like group 18, who are noble gases. So they want to have 8 electrons in their outermost shell. Okay, so the first bonding that I'm going to talk about is ionic bonding. And you already have a good idea of what ionic bonding is because we just finished this unit, okay? So ionic bonding is the attractive force between a cation positive charge and an anion negative charge, okay? Ionic compounds form these really tight, compacted things called lattice structures, which is what I have over here, okay? Sodium is red, chlorine is green. We know that sodium wants to give 1 electron, chlorine wants to gain 1 electron. So sodium and chlorine have a 1-to-1 ratio with each other. And what ends up happening is they just continue that 1-to-1 ratio depending on how much of the substance you have. Okay. They look like they're separated by this line here, and it looks like a bond, but let's consider this, right? We know that the positive charge and the negative charge will form a tight packed together because we know that opposites attract, right? So what we say the attraction is between sodium and chlorine is an electrostatic force, right? So think about it in this way. If you want something from somebody, say like a girlfriend or boyfriend or what have you, you're going to get really close to them, right? Because you're very attracted to each other. It's sort of the same concept here. So that's ionic bonding. The next big group of bonding that we're going to talk about is this thing called covalent bonding, okay? Covalent bonding is another attractive force between atoms, okay? Covalent bonds form instead of transferring their electrons, so one gaining and one receiving. What's going to happen is the atoms are going to share their electrons, okay? So nobody's gaining, nobody's receiving. They're just kind of sitting there harmoniously together, sharing the electrons, okay? A group of atoms held together by covalent bonds is also referred to as a molecule. So if I say molecule, you should be thinking sharing electrons, covalent bond, okay? There are 2 different types of molecular structure. You can have a molecular solid, which is individual molecules are attracted through weak forces between molecules. So what that means is, if I look at these covalently bonded water molecules, right? Hydrogen and oxygen are sharing electrons. Hydrogen and oxygen are sharing electrons. We know that water is H2O, okay? So in a glass of water, what's happening is all of our waters are doing this thing called hydrogen bonding to the other water, okay? You'll notice that this line is dashed though. That indicates that there's not a sharing that's happening, but just like with our ionic compound, there's sort of an attraction to each other, so they kind of line up like this, okay? And the space between them is the force that's kind of holding them together, which is referred to as a hydrogen bond. So there are 2 different types of covalent bonds. We have a polar covalent bond, and we have a non-polar covalent bond. The first one I'm going to talk about is the polar covalent bond. So if we look at this image here, again, we're talking about water, okay? Oxygen and hydrogen are sharing their electrons, okay? Nobody is fully giving, nobody is fully receiving. They're just kind of sharing their electrons together, okay? However, somebody is going to want the electrons more than the other person, right? If we think back to Unit 3, this is our electronegativity, right? Electronegativity is the want of the electron in the bond, okay? So if we're looking at this, I have to figure out who wants the electrons more, oxygen or hydrogen. Now, in this case, it's telling me that oxygen wants the electrons more, which indicates that it has a higher electronegativity, meaning in the game of tug of war between oxygen and hydrogen, oxygen is pulling the electrons towards it more. So with that being said, the oxygen is going to have a negative charge. Now you'll notice it's not a negative like we do with our anions. It has this little lowercase delta symbol, okay? That lowercase delta symbol means partial, right? Not whole, like anions, but partially negative, okay? So that means that oxygen is partially now negative, right? So it acts like a negative charge. Where the hydrogens are losing the game of tug of war, oxygen is pulling the electrons away from it, they're going to have a partially positive charge. Okay, so since this molecule now has two separate sections in it, one part is negative and one part is positive, that means that it has poles, right? So the one side is a negative pole and the other side is a positive pole. Okay, so since there's two poles, like we have with like an ionic compound, this is going to be considered a polar covalent bond, meaning one atom in the bond wants the electrons more. Okay, and then we can think about the opposite. The nonpolar covalent bond is they are having an equal sharing of electrons amongst the molecule. Okay, so when we're talking about a hydrogen-hydrogen bond, since they have the same electronegativity, nobody wants the electron more than the other. So that means that they are not really having a game of tug of war. They're just kind of standing there and saying, I'm okay. I don't need to win. Okay, so then that means that we have no poles. There is no partial negative. There is no partial positive, which then indicates that this is a non-polar covalent bond. Equal sharing of electrons. Okay, I have two more here. This is the covalent network, okay? It consists of atoms forming covalent bonds in multiple different directions, okay? So covalent bonds, again, we have to remember they're sharing electrons, but what ends up happening is you have covalent bonds occurring all over and it becomes very, very strong, okay? We know this because diamond has a covalent network, right? And it is the strongest element or strongest substance that we have. Nothing can scratch diamond, okay? Graphite is another form of, so diamond is carbon and graphite is the same. It is a form of carbon. And you'll notice that the reason why they're different substances is the way that their covalent network is set up, right? So diamond has more of like a tower-like structure where graphite is just sort of like layers, okay? So graphite is much softer than diamond. So that's a covalent network. And then the last bonding that we have is this thing called metallic bonding. We have is metallic bonding. Metallic bonding is special attractive forces between closely packed metal atoms, which are referred to as cations, okay? This involves free floating electrons that extend into a three-dimensional structure. So let's think about this. If I have zinc metal, right? Like I have a piece of metal. You can think about it in any terms you want to think about it. Metal or zinc, copper, iron, aluminum, anything. Those atoms have electrons that kind of move through it like a wave would, okay? Which indicates that since these electrons are free flowing, that means that I can then use that to, say, conduct electricity, right? Because we know metals conduct electricity. So those metallic bonding features are very important, okay? So that's the introduction to this lab. The next part is we're going to do some pre-lab questions. I'll walk through the procedure, the lab will happen, and then I'll explain the formal. Thank you.